This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to talk about the Cartesian Coordinate System. But actually the Cartesian Coordinate System has a very interesting story and how it's been invented. It's actually an old story that describes how the 17th century philosopher and mathematician René Descartes invented the system that has been the foundation of algebra, and he actually invented this system while he was lying in bed and he was sick. So the story goes like this. Basically, Descartes was sick, lying in bed, and he was watching a fly crawling on the ceiling, when he realized that he could basically describe the location, the exact location of the fly with respect to the adjacent walls of the room. So for example, suppose these were the walls in the room, and that they were of course perpendicular. I mean, walls in most cases are perpendicular, and this was the fly. And so he said that he must have thought to himself, I mean, I would think about this way, but he must have thought about this way as well. So he must have thought to himself, okay, so if this is this wall, so I can say that the displacement of the fly from this wall is this much, this distance, and so the displacement of the fly from this wall over here is this distance over here, this vertical distance, and here we have this horizontal distance. And so if I make up an ordered pair of numbers, for example, here I say the displacement from the vertical wall is, let's say, x units, and the displacement from the horizontal axis, or from the horizontal wall is, for example, let's call it y units. Then where these two numbers meet, something like this, where these two numbers meet, that would be the exact location of the fly on the ceiling. So he came up with this idea, and well, of course he developed all the necessary parts of the system, and he actually came up with the idea, and he invented the Cartesian coordinate system, and he called this the x-axis, this one the y-axis, and of course these axes they extend this way and this way as well, and so you have a plane, something like this, and this goes to plus infinity, this goes to minus infinity. This again, in the vertical direction you go to plus infinity, and then this extends to minus infinity. And so this system basically divides the plane into 4 sections, as you can see. The sections are basically, this is the first section, or called the first quadrant. So this is called the first quadrant. This is the second quadrant. This is the third quadrant, and this is basically the fourth quadrant. And they have been labeled counterclockwise, as you notice. And each of these is basically quadrant. Now Um, Now the way this system is organized, where the the point where the x-axis and the y-axis meet is called the origin, and the coordinates of the origin in the Cartesian coordinate system is it's 0, 0. That means that you have no displacement from the x-axis. You have no displacement from the y-axis. Your x value is 0, and you have no displacement from the x-axis. That means your y is 0. So that's the origin. And from the origin, when you move on the x-axis to the right, you're basically moving in the positive x direction. From the origin, on the x-axis, when you move to the left, you're basically moving in the negative direction. Again, from the origin, when you move upwards on the y-axis, you're moving again in the positive direction. From the origin, when you move downwards on the y-axis, you're moving in the negative direction. And so, in order for us to be able to define the exact location of any point in this system, we need basically units. So these axes, x and y, have been divided into have been labeled with basically equal distances on each axis. For example, this is +1, +2, +3, and +4, +5, +6, +7, and +8. And so this is again on the y-axis the same story: 1, 2, 3, 4, 5, 6, 7, and 8, let's say. And if this point, for example, was over here, if I had the fly over here, I would say the displacement from the y-axis is 1, 2, 3, 4, 5, 6, 7, 8 units. So that would be my x coordinate, and then I would say the displacement from the x-axis is 1, 2, 3, 4, 5, 6, 7, 8, 9 units upwards, of course, and that would be my y coordinate, and this would be the coordinates of the fly in the Cartesian coordinate system. And then based on this, I would be also able to, of course, locate the flight in the plane. And this pair of numbers that you see over here that describes the location of the fly in the plane or on the plane is basically called an ordered pair. So they call this an ordered pair. And so ordered pair. And also you also notice we also talked about the fact that when you move on the x-axis, when you move in the left direction, you're dealing with negative numbers. For example, if there was an object over here, and I wanted to know where the object is, I would simply say, okay, so the object is here, and so this is 1, 2, 3 minus 3. This is my x coordinate, and 1, 2, and 3 minus 3, this would be my y coordinate. So this would be how I would describe the location of an object for example, in the third quadrant. And well, there is one more thing that you need to know here. On this, in the Cartesian coordinate system, basically you're dealing with this is basically a representation of the relationship between some x and some y. And it's not always about location. It could be anything. For example, you want to study how a function changes over time. For example, this axis could represent time, for example, and this axis could represent a wave that's changing with respect to time. And I mean, most of the time you can see that, for example, the function of the sine basically is something like this. For example, you draw a function, and this function over here, and as you can see, it's changing its y values as time goes by. And then in that case, that would be time. The x-axis would be time, and the y-axis would be, for example, sine x. So in this case, you would be studying the changes of sine x with respect to time. As time goes by, your function goes up and comes down, and again goes up, and so on and so forth. So the Cartesian coordinate system is basically a great tool to study the relationship, to study any sort of relationship between any two sorts of variables like x and y. And so in this chapter, we're going to learn a lot more about this system. I'll see you in the next video.